for centrifugal impellers can share the same diameter and still behave very differently. The reason is not the label on the motor. It is the blade direction, passage shape, and exit velocity that the impeller creates. Let us compare radial, forward curved, backward curved, and airfoil blades without pretending that one design wins everywhere. First, read blade direction relative to rotation. A radial blade points almost straight from the hub to the rim. A forward curved blade bends toward the direction of rotation at its outlet. A backward curved blade sweeps away from rotation. An airfoil impeller is normally a refined backward inclined design whose blade has a shaped aerodynamic cross-section. It is not just any backward curved wheel with a different name. The radial impeller uses strong, open passages. Its straight blades tolerate dust, particles, and material buildup better than many closely spaced curved designs, and the wheel can be built for demanding industrial duty. The trade-off is that aerodynamic efficiency and sound are usually not its main strengths. Even here, material, wear liners, clearances, and particle size must match the application. The forward curved wheel uses many short, narrow blades. At the outlet, blade speed and relative airflow combine to create a larger tangential velocity component. That lets a compact wheel deliver useful flow at relatively low rotational speed, especially inside a scroll housing. But absorbed power can continue rising as airflow moves to the right of the curve. The motor must therefore be checked across the expected operating range, not only at one nominal point. The backward curved wheel turns the outlet edge away from rotation. The exit velocity triangle has less whirl than a comparable forward curved design, so less energy is left as unnecessary tangential motion. Well-designed backward curved impellers can reach higher efficiency in medium to high pressure, and their absorbed power curve often peaks and then levels or falls within the intended range. That typical non-overloading tendency still has to be confirmed on the tested curve. An airfoil blade adds a carefully shaped leading edge, thickness distribution, and trailing edge to a backward inclined passage. In clean air, the profile can reduce separation, drag, and aerodynamic noise. But fouling changes the shape the air actually sees. Dust, grease, corrosion, impact damage, and manufacturing error can erase the advantage, create imbalance, or increase vibration. Airfoil performance depends on profile accuracy and cleanliness, not on the word airfoil alone. Here are Longwell product references: a compact forward curved blower, an open backward curved wheel, and an RLM airfoil impeller. The hardware makes the difference visible. The forward wheel packs many shallow passages into a scroll. The backward wheel uses fewer, wider swept blades. The airfoil wheel uses large-shaped blades built around a strong hub and backplate. A radial industrial wheel can use even more open, straight passages when contamination tolerance dominates. Now place the four designs on one engineering map. Radial starts strong for dirty or particle-laden flow. Forward curved is attractive when compact size, lower speed, and modest pressure matter. Backward curved is a common choice for efficient clean air AHU, CRAH, plug fan, and ventilation duty. Airfoil is worth evaluating when clean air efficiency and aerodynamic sound justify the tighter manufacturing and cleanliness requirements. These are tendencies, not guaranteed rankings. Never select by blade name alone. Compare verified curves at the required airflow and pressure. Check absorbed power over the full operating range, efficiency, sound spectrum, speed, material, temperature, corrosion, dust or grease loading, erosion, balance grade, housing or plenum geometry, inlet clearance, maintenance access, and available space. A different blade changes the fan curve, so it also changes the point where the fan meets the system. The best impeller is the one whose tested curve and construction fit the real system. For a 4-way impeller and duty point review, visit longwellfans.com.